Alright, for tonight's homework, I'm going to have you watch, do all the work, and then write the 5 magic words. And then I want you to know that tomorrow there will be a problem on the test that has you read it and show me, again, just a general understanding when you read it. I'm going to have you read the problem again and give me a little bit more depth. And I'm going to have you read it again and give me some more detail. So there will be a problem like that. So this first one here, again, what I'd like you to do is to write the triangle again, but make sure it looks like the first one here. So I'm going to redraw it so it's lined up just like the first one here. I'm going to make sure I put the numbers in the right place. That 5 goes in the small place. That 8 is on top, 12 on the bottom. And then it's easier for me to see that these pairs are corresponding, the 24 and the 12, the 16 and the 8. So when I do my checking if they're similar, I need to see that all these ratios are the same. So I'm going to go 10 over 5, and I'm going to keep going with that pattern. The big length over the small corresponding length. So 16. So again on this one, 10 over 5, keeping consistent. 16 over 8, keeping consistent. 24 over 12, from big to small. And you can see all these equal 2. 10 divided by 5 is 2. 16 divided by 8 is 2. 24 divided by 12 is 2. If one of these was not 2, that would have been a no. The first word is do. Do. Alright, next problem. I would like you to draw the triangle again to make it reflect the way the first one looks. And put all the numbers in the right places. 4 on top, 3 is the small piece, 6 is the slant. And then again, be consistent. For this ratio, you only have 2 fractions. And make sure one of them has the x in it. So I'm going to choose to go x over 4 just to set up some kind of pattern. X, the long side, over this, the small side, x over 4. And then to stay consistent, I'm going to do any other pair of numbers in that direction. I could do 12 over 3, or I could do 24 over 6, either one. But again, if I do x over 4, I have to do 12 over 3 in that same pattern there. And then of course I'm going to crisscross multiply. 3 times x, 4 times 12. 3 times x gives me 3x. 4 times 12 gives me 48. Divide both sides by 3. And that gives me 16, I believe. And that would make sense if that's 16. 4 times 4 is 16. 6 times 4 is 16. 3 times 4, 12. Going backwards, dividing by 4 or timesing by a fourth. 12 times 1/4. 12 divided by 4, 3. 16 times 1/4. 16 divided by 4, 4. 24 times 1/4. 24 divided by 4, 6. Going this way, you're timesing by 4. Going this way, you're timesing by 1/4 or dividing by 4. The second word is problems. Problems. Alright, next, scale factor problems. For these, make sure you're putting the image over the preimage. I would like you to redraw these again. So I'm going to draw it so they match up. I'm going to make sure I put the numbers in the right place. 6 on the bottom, 3 on the side, 7 on the slant. This is going from small to big. So I'm going to put the new length, the image length, over the old pre-image length. The new length is going to be bigger, so the number on top is going to be bigger. The old length is smaller, so these are going from small to big. Big number on top, small number on the bottom. Choose any pattern. 6 to 48, you could do 48 divided by 6. 3 to 24, 7 to 56, either set. So I'm going to choose to do 48 over 6. 48 the length that it grew to, divided by 6, the length that it used to be. Gives me a scale factor of 8, which makes sense. When I'm going this way, I'm timesing by 8, timesing by 8. The other problem, you're shrinking, so the scale factor is going to be a fraction because you're dividing down. So I'm going to have you redraw the scale factor triangle. I'm going to put the real numbers here, 2, 4, 7, going down. Again, my new length, the one on top of the fraction, is going to be a smaller number. And the old length, the number on the bottom, is going to be bigger. That's why these are fractions when you're going this way, when you're shrinking, when you're going down, dilating down. So I'm going 7 on top, I believe, my image, over 35. So my image 7 over 35. I could also do 4 over 20. I could do 10 on the bottom of 2. So I'm doing 7 on top over 35. And this could be reduced down by dividing both top and bottom by 7, which gives me the scale factor of 1/5. And again, don't make the mistake of thinking that's 5. I'm timesing these by 1/5. 35 times 1/5 is 35 divided by 5, 7. 10 times 1/5 is 10 divided by 5, 2. 20 times 1/5 is 20 divided by 5, 4. Going backwards, timesing by a whole number. Going shrinking, timesing by a fraction. All right, transformation problems. For this one, again, I'm going to give you the initial image and then 3 transformations. So I'm going to have you write down the coordinates of A, B, and C, where A is 1, 4, B is 1, 1, and C is 6, 1, or 5, 1, I'm sorry. I'm going to dilate by a scale factor of 2, which means this is becoming twice as big, or every coordinate multiplied by 2. The point 1, 1 will become 2, 2. The point 1, 4 becomes 2, 8. The point 5, 1 becomes 10, 2. Again, timesing every coordinate by 2. Or I could have drew my lines of dilation. Over 1, up 1, over 1, up 1 gives me all the points to dilate. Over 5, up 1, over 5, up 1 gives me all the points to dilate. Over 1, up 4, over 1, up 4 again gives me all the points to dilate. So for this one, 2, 8, 2, 2, and then 10, 2 gives me the bigger triangle. And then that's C prime, that's A prime, and then B prime. And you can see that triangle is twice the length, twice. This is 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6. It used to be 3, doubling. Now I'm going to take that and reflect it over this x-axis line. So I'm going to reflect every point equal distance across that line. So if first one is 2 above, the reflected point equal distance across that line 2 below. A, 8 above, the new A double prime, 8 below that line you're reflecting across. C prime, 2 above, the new C double prime, 2 below. That is the reflected image. And then the next thing you're going to do is translate it down this arrow. The arrow is telling you where you're translating this. Going down this left to right. But you need to map that out. This left to right motion is left 1, 2, 3, 4, 5. Left 5 boxes, down 4. Left 5, down 4. So each point is going to go left 5, down 4. Left 5, down 4. Left 5, down 4. The third word is over, over. So each point, left 5, down 4. Left 5, down 4. Left 5, down 4. So left 5, down 4. Left 5, down 4. And then those coordinates, A triple prime, -3, -12. B triple prime, -3, -6. C triple prime, 6, -6. So the coordinates, if I ask you, -3, -12, -3, -6, and then 6, -6. Or I'm sorry, 5, -6. All right, last problem. The fourth word is and. And. All right, this one looks like I'm rotating it. And again, you got to know your rotations. So A, B, and C, for rotations to double check, I would like you to write the coordinates and then see how they flip. And depending on the direction you're turning, the one of them becomes opposite and negative. So A is 2, 2. B is 4, 6. C is 2, 6. If I turn 90 degrees to the left counterclockwise, the points will flip and the left coordinate becomes opposite or negative. If I do a quarter turn to the right, quarter turn 90 degrees clockwise, the points will also flip, but that right side coordinate will be negative. Quarter turn to the left, flip them, left side negative. Quarter turn to the right, flip them around, make that right side negative. 90 degrees counterclockwise to the left coordinate after flipped becomes negative. 90 degrees quarter turn to the right, the points flip and that right coordinate becomes negative. So all of these will flip. 2, 2 just flips to become 2, 2. But since I'm turning to the left, that left one becomes negative. So not only flip them, but make that left one negative. So this flips and becomes -6, 4. This becomes -6, 2. So when I rotate it to the left here, I think I make a little mistake that I'm going to fix. -2, 2. -6, 4. And again, it looks like at first I go over -7, 4, so I will fix that. So -6, 4, I'm over one box extra. I will fix that shortly here. So again, that triangle should be right here at -6, 4 and -6, 2. And again, I'm looking at that saying, wow, is that now a scale factor? 1, 2, 3, 4, 5? I'm like, whoa, this is only 4. That can't be 5. So that's what keyed me on this mistake, that I drew it too long. 5, 4, not quite a dilation, so I think I made a mistake there. So I'm going to fix that. So there it is. There's the triangle where it should be. -6, 4, -6, 2. You can see just rotated 1, 2, 3, 4, 1, 2, 3, 4. And then again, to check, it looks like a dilation. So there's a couple ways you could check. You could count the lengths of the old one and then the new one in C and find that scale factor if it's a scale factor. Going from 4 to 8 looks like multiplying by 2. I could look at the coordinates and see if I'm timesing the coordinates by 2, which looks like I am. -6, 2, -6, 4. Looks like the coordinates are doubling. So again, another way to see it's a dilation. So this is a 90-degree counterclockwise rotation around the origin. And then it's a dilation by a scale factor of 2. Technically through the origin as well. So a dilation by a scale factor of 2 through the origin. Why don't you write that for me? Through the origin. Dilated through the origin. The last word is over. Over. Good luck.